So when we say clustering, it means unsupervised. So clustering cannot be supervised, right? And when we say, for example, classification, it means it is supervised. Okay, so now let's look at this example right here. So how does hierarchical clustering work? Hierarchical clustering is very different from, it differs from K-means. The basic idea is K-means we need to set the number of clusters, and somehow we need to split the data into K clusters. Hierarchical clustering considers each point, each initial datum, okay, so this we can call it, we can call it data point, or also we can call it datum, okay? So it considers each point as a cluster, and then works in a way that it will put points together, cluster them together until we get a whole big cluster that joins all points. So slowly, in an agglomerative manner, we're merging clusters, okay? We're putting, merging these small clusters together. So for example, here, let's say we pick the closest points. So how do we do the merging? We always merge the clusters that are closest to each other, okay? So for example, we know that these points are close to one another. So this is maybe the distance between the points. So let's put distance or height, distance between points. So these points are very close. These two are also close, so maybe around the same distance, okay? Now, the next step would be to merge, take the closest point, find the closest cluster to this one. Let's take the first one, right? This cluster. What is the closest cluster to this to the yellow one? It's because now, if you guys see, when I connected them, these 2 points, they form a single cluster. How many clusters we have? So we have 1, 2, 3, 4, 5, and 6 clusters, okay? So next, we know that this point is very close to these guys, so we can somehow put them together, right? So this is merging. So now I have a new cluster composed of 3 points. And then the next we'll do the same. So here, these 2 clusters are far away, so I'm not going to merge them right now. So I need to look at 2 closest clusters. So the next closest clusters by comparing, basically the pairwise, we perform a pairwise comparison between all possible existing clusters in the current run. And then what we do, we pick the closest one. So it's quite intuitive. The closest one is this one. So maybe it's slightly higher than the green, okay? And then the next one would be the distance between these two clusters is smaller than the distance between these clusters. So what we'll select is this one. So next point, I'm merging, adding this point to these new cluster. Okay, so slowly merging clusters basically, okay? And then the last step is pre-final. So this one, maybe these 2 guys are close, right? And then the final one would be joining all clusters together. So this is basically what we call hierarchical clustering. And here, this we call a dendrogram, okay? Now, if we want to, the good thing about hierarchical clustering, it merges the closest clusters together in an iterative manner, but we don't need to specify the number of clusters, right? We don't need to input the K. So if we want to cluster our data into 2 clusters, how can we do that? So you can see that here, originally, we have 2 clusters, okay? So we need to cut at a threshold the dendrogram at a particular D value. For example, if I threshold it at this level, then I'm gonna get all these points, right? So this is cluster 1 and this is cluster 2. So we'll get cluster 1 and cluster 2, Okay. Now, if I threshold it at a different, another different value, so for example, right here, how many clusters will I get? 3. Very good. So cluster 1, which is a singleton, cluster 2, and cluster 3. So this is the, like just the concept of hierarchical clustering or agglomerative clustering. So there are many variants of hierarchical clustering. But let's look at how this works, just the key steps. So first thing, we start with n groups or n clusters, like n points, okay? So in the beginning, we have n points, right? So these are our data points. And we merge two closest clusters or groups at each iteration. So at each iteration, we merge two together, okay? So to do the merging, there are different, we need to compute the distance between two clusters. So remember here, like as I mentioned earlier, we need to compute the distance between clusters, like pairwise of, existing clusters at that current iteration. To do that, there are different metrics or distance metrics we can use. The first one is a single link, and that's what I used here in the example, which is the minimum distance between 2 points belonging to these different clusters, okay? So let's say, for example, these are my points. So this is cluster. You have two clusters here. So the closest points from cluster 1 to cluster 2 are these points. So this is from cluster 1, cluster 2. This is the min distance, what we call the single link, okay? So we know that these clusters are very close based on this distance, the distance of their closest points, okay? Now, the other way is to use the complete link, which is a stronger assumption because we're taking the max. So the maximum distance between these clusters is like taking the far away points, okay? So this is the maximum distance, and we can use this criterion to perform hierarchical clustering. And the last one is basically taking the average link or the centroid. So we will compute the centroid of each cluster and then compute the distance between these centroids. So for example, right here, this is centroid of cluster 1, centroid of cluster 2, and then this is the distance, this is the average link, okay? Great. So now this is another example where we're using the single link clustering. So we have, just to review very quickly, first thing, we have different points. These are our clusters. So how many clusters we have in the beginning? 1, 2, 3, 4, 5, 6. Then in the first run, we pick the closest points. So the closest points here we have BA, then CD, okay, because they're too close. So we build the first cluster 1, iteration 1, and they're like at distance 1, okay? So this is the unit distance right here, it's 1. And then we move next. The next two closest clusters, it's not these guys or these guys, right? It's CD. So we need to perform a pairwise comparison between all clusters. Compute the distance between all of those. So, right, so let's say now we have this cluster. I need to compute the distance between this cluster and point E and C, D, etc. And the same, so I take all other clusters. So you can see its complexity is more than quadratic because we need to perform pairwise distances, right, between clusters. So when we do that, we can see that the closest clusters are C and D, okay? So CD, then the next for AB, the closest point actually is here. E is closer to this cluster than when we look at F, the distance between F and cluster CD, okay? So the next point will be E. And then comparing these, now we have merged those 3 points together, and we have these 2 points together and a singleton. So we need to compute the distance between, okay, I want another color, between these, and this one. And we notice that these are the closest, okay? So we merge them. right there, okay? And then that's it. Once we merge them, we have 2 clusters left. And we do the merging of all of those guys right there. So you guys see, it's kind of simple. Now, to do the clustering, we can threshold at a particular level. So if I threshold right here, how many clusters we have? We have 1, 2, and 3. Okay, great. Right, so that's it for hierarchical clustering. Now, if we want to compare hierarchical clustering and K-means, just a very simple comparison.
Is it slower than K-means?
It is slower than K-means, exactly. So hierarchical clustering is more, it's more time consuming. So if you want to apply it to a large data set, it will take a lot of time. So it's better to use K-means. So in this case, if you have a very large data set, K-means is a better option. Now, this is a disadvantage of hierarchical clustering, right? Now, what is a drawback of K-means? One potential drawback of K-means. Yes, you need to fix the K. So you need to select the K for the K-means. So this is a parameter to tune. As for hierarchical clustering, you don't really need to select it directly, at least. Well, you need to threshold at some point, right? But still, the results you get for K-means largely depend on the K. So K-means also is very sensitive to the initially selected K points, okay? K centroids. However, hierarchical clustering, now something positive, hierarchical clustering is more stable. So even if you perturb the data, if you're like run it many times, you will end up with the same hierarchy, okay? So this is one advantage of hierarchical clustering. K-means is not stable. It largely depends on the initialization.